Hello, we're the prosthetic foot shell failure prevention team, Soulmates. My name is Colton Arbuckle. This is
Chris Mankey.
And I'm Jacob Rodriguez.
Our sponsor shown in the photo is Dana Cummings, who is a former Marine and an avid surfer who uses a lower leg prosthetic. He is the founder and president of the company AMP Surf, which is a non-profit organization established to promote, inspire, educate, and rehabilitate all people with disabilities and their families through adaptive surf therapy and other outdoor activities.
prosthetic foot shells are not currently designed for active lifestyles. They are more designed for geriatric use. Active customers need foot shells to be more robust to withstand the lifestyle they desire.
We did an iterative design process with the goal of creating a DIY kit with readily available materials that anyone can easily acquire to extend the life of current foot shells. The team tested different materials to design an initial prototype, and then entered a cycle of testing the prototype, designing a new prototype from the results, and then building a new prototype until the team felt the current prototype was ready for real-world scenarios. The final design is a set of materials that people can acquire and attach to their current foot shells to extend the life of their foot shell. The main materials included are high-density polyethylene, shoe rubber, and barge cement. These can easily be acquired at most major stores. The team made a video that includes a build process with more description and other tools that you would need for the build process if anyone will want to make one themselves.
Since we chose to have an iterative design, we did a lot of testing. To start the project, we tested different adhesives with the PosiTest ATM adhesion tester. This adhesion testing led the team to select barge cement as our adhesive of choice for the verification prototype design for our external sole adhesive. To select the external sole material, the team tested different soling materials by repeatedly dragging them across a 10-foot section of concrete with a 10-pound weight to check for durability. We were checking to see if the friction would cause the material to wear. This test led the team to choose rubber soling material for the external sole. Since the carbon fiber shell can poke through the foot shell, the team decided on a polyethylene insole to protect the inside of the shell from puncture. To verify our design, we first set out to ensure that our adhesive and external sole material would last when walked on for several weeks. We applied the external soling material to shoes shown on the right to simulate what our sponsor would put his shell through. Each team member has been regularly wearing the shoes since the beginning of March, and the barge cement and soling rubber combination has stayed adhered properly on all 6 shoes. Once we put the verification shell together, we simulated putting the shell in and out of a shoe for a year, and all parts remained intact. We also tested against heat to ensure that if the shell was left in a hot car on a summer day, it would not deform. Sadly, when the shell was given to our sponsor to test, the external sole did not stay adhered like the team found in the shoe test. We believe this was caused by the shell being relatively smooth and not having as porous a material as the bottom of the shoes. The insole, however, has proven to work perfectly and will help extend the life of the foot shells.
To wrap this up, there are a couple acknowledgement and thanks the team wanted to give. We wanted to thank the Materials Engineering Department Chair, Dr. Trevor Harding, for allowing our team to borrow the PosiTest adhesion tester equipment. We also wanted to thank Meredith Rubin for aiding with purchase orders of our materials. We wanted to thank our senior project advisor, Sarah Harding, for support and guidance throughout our project. And lastly, thank our sponsor, Mr. Dana Cummings, for insight and assistance throughout testing.